13.8 billion years ago, there was an event so extraordinary that without it, nothing would exist. It was the beginning of our universe, a time when an enormous amount of energy in an infinitely small space violently expanded, creating our universe and everything that we see around us today. It is perhaps our greatest scientific achievement to understand the history and nature of our universe. But there is a problem. The theory doesn't explain where the universe came from. So what caused this remarkable event? What caused everything that we see around us to exist? And why is there something rather than nothing? We asked 6 scientists at the University of New South Wales, specialising in various fields of physics such as astronomy, theoretical physics, particle physics, cosmology and astrophysics, what they think happened before the Big Bang.
Before the Big Bang, it's an interesting question because that's...
I'll just repeat, there's no data to base anything on, right? It's an open question at present.
Oh dear, that's a really big question. Well, I try not to think of what happened before Big Bang because I don't think there is an answer for it. You know, there are certain theories. Some people think, oh, our universe is recurring, so maybe there was another universe which collapsed and so on. But at the moment, I don't think we know it, and you know, I like to base my thinking on what we actually know.
So the thing I always find weird as someone who isn't a cosmologist talking about it is that everything we know in space was in the Big Bang, but everything we know of time was as well. Time's just another dimension. So if space and time were created and had a genesis out of the Big Bang, the idea of before it doesn't have a meaning in terms of how we understand time as a thing. What that means is that it could be everything and nothing. We've just got no way of knowing in the framework of our current ideas and our current theories.
The origin of the universe is the one we understand the best. And this can seem paradoxical. People might think, well, isn't the universe being everything the hardest thing of all to explain? But from the point of view of physics, we have a pretty good framework for understanding how the universe can pop into being.
From my understanding, it's just sort of really dealing with time and space. And so the actual Big Bang moment, called the Big Bang Theory in a sense, that suddenly expanded in space and time. It wasn't an explosion, because an explosion requires a difference in pressure. It's just this sudden expansion of space and time in a linear fashion in some way. As far as we know, at least time in a linear fashion. Space is actually increasing at an accelerated rate now, apparently. So before that, who knows?
That's effectively a point before time existed and the universe as we know it existed. And since everything that we can record happened after the Big Bang, asking what happened before the Big Bang is kind of meaningless to me. It's kind of one of those odd questions where it's an interesting thought experiment, but it has no real value because we can't test it or probe it. So anything and everything basically is the answer, is what happened before the Big Bang.
I can give you alternatives. One is that time itself began with the Big Bang. Another possibility is that the present expansion will finish and turn round and we will go into a big crunch, perhaps even into a big bounce. So there will be another Big Bang, another expanding universe. We could be just one expansion of a whole sequence of them. However, the limited amount of data we have suggests that that won't happen, that the expansion will continue forever. But as I say, it's all speculation that time began with the Big Bang, so there was nothing before it.
At the moment, we can sort of push our understanding of universe to very early times, like 10 to minus 40 something seconds, where we actually understand a bit of physics about it. But beyond that time, we really cannot say much. And this is like, you know, working with black holes. You just can't get to that singularity in the black holes, and you can, yeah, that's a good time for, you know, for coffee or just discussion with wine. Yeah, oh, what could happen? But you know, it's like talking about anything like religion. you just don't have tools to answer this question, and yeah, so now, you know, we can hypothesize multiverse theory, a lot of different things.
What about the universe from something? Suppose there was something there before. Well, a popular idea at the moment, it's been around for about 20 years, is that the Big Bang, what we call the Big Bang, is the origin of our universe, but not the entire physical thing. It's that it's one of many bangs scattered throughout space and time, and the assemblage of all of these things is truly eternal, has no beginning and no end. And so within that overall framework, universes like ours can pop into existence by some quantum tunneling process or something, and away they go, and they have their life cycle of birth, evolution, and maybe death, and we're just one instance of that. Now, you might think, well, that solved the problem of what happened before the Big Bang. Of course, it hasn't solved the problem of physical existence, because there still have to be laws of physics in this wider multiverse, this overall superstructure. And one could ask, well, where did those laws come from? And was there a beginning, an ultimate beginning, to this whole assemblage of things? And if there was, then we're right back to the same problem as we had before. So we're sort of moving the bump in the carpet here, and yet, so long as we have fixed, immutable laws, it seems to me that there's no other way of getting around the problem.
If it becomes sort of traceable in that regard, that suddenly everything and anything was possible, and if you've got an infinite amount of space, anything is possible inside that. So you get repetitions, and this is the whole sort of parallel universes theory that some cosmologists put out, that although our universe is bound and finite, it has a size, there's no discernible edge to it. There's probably material of similar properties beyond that we just can't see because it's outside of what's called our light cone, I think it is, that the light from those the bits and pieces outside of our light cone will never reach us, therefore we'll never be able to see that they're there, because the speed of light is finite. So it could be equivalent carbon copies of ourselves doing slightly different things, doing the same thing. Then suddenly we become a lot less special, a lot less unique, and possibly even a lot less interesting in terms of being part of the universe. I mean, we like to think of ourselves as special, but if we're just a natural outcome and we just happen to be a part of every universe almost in some way, something like us is, then yeah, suddenly it's a bit sad, really.
Well, as I said, that's one scenario. Another is that time and space are just 4 dimensions out of 11, and that collisions took place between membranes in higher dimensions and kicked everything off. But again, there's no data. There's nothing to test it with. Yeah? It's all speculation.
Comes in the idea of the multi-universes thing, that you might have all these universes coalescing with one another, and then suddenly they find this path that seems to work, and they're projecting out from that. Maybe. I don't know. Again, it's all speculation because we have no probe to actually analyze what happened before, because the globe, the cosmic microwave background, is hinging really us what allows us to see the Big Bang moment. And then there's the actual Big Bang moment, which is obscured by this very sort of thick sort of background, where we believe that's when the first matter produced the first light, and in a coherent sense that we can actually understand for ourselves. And we see this everywhere, of course, and we only see the observable universe. So if I look that way, I'll see it. If I look behind me, I'll see it. If I look that way, etc. It's all around us. So we're looking in some sort of bubble in respect to the universe. So it's only the observable universe. What lies outside of that? Well, again, we don't know.
Trying to find an analogy for why. Imagine that you were flat, that you were two-dimensional, and you were moving around on the surface of a sphere. You've blown a balloon up, you've drawn a man on the balloon, and that man's moving around. How can that man on the balloon perceive the third dimension towards the interior of the balloon or the exterior of the balloon? They can't, because they can only move along the surface of the balloon. Now, they'd learn something about it by the fact that if they go as far as they can in one direction, they come back to where they started. So that gives them some idea that the space that they're on is curved, which is kind of what we do a bit with the universe anyway. That's how we understand the shape of the universe. So it's even more than that, but that's a good place to start visualizing it, is that you can be in a situation where there are things beyond your perception that you just cannot measure, you can't control. If you tried to get that person to imagine something totally a different balloon somewhere else, that's beyond their imagination, well, it's not beyond their imagination, but it's beyond what they can measure, beyond what they can see, because they've got no way in their two-dimensional surface of the balloon of getting off that surface and going elsewhere.
Because I think that's what you need when it comes to cosmology, because you need this outside-of-the-box thinking in order to understand what's happening to the universe as a whole.
The name of the game changes quite dramatically, however, if you don't regard the laws as absolute, universal, infinitely precise, transcendent mathematical relationships, but you regard them as something that can evolve and change and be part of this package. And then you're in with the chance of trying to explain the universe, or a multiverse if you prefer, in terms of co-evolving laws and states in a way that there's a feedback from the one to the other. And in particular, you have to have feedback through time, otherwise you can't explain in a self-consistent way. So my dream is that one day we'll be able to explain the universe in terms of laws that themselves are explained by the universe in a sort of loop, and that this loop will stretch into the past and stretch into the future, and that the reason the universe is as it is will have to do with this two-way arrow of time connecting principle. No, it's not causation. Nothing we do now can change the past or alter the past or even signal the past. But what we do now, we know connects with the past. We know this from the foundations of quantum mechanics. We know, Einstein called it spooky action at a distance, because it referred to what's going on here and here simultaneously being connected, but a change of reference frame means that this is in the past of that, and it's still connected. So we know that quantum physics connects the present with the past, but it can't be used to change the past or signal the past.
That's another big question, which I don't think anybody's got a good answer, although, see, one thing which is interesting, it's the arrow of time. So why do we have the arrow of time? And I think I'm closer to understanding this concept than the time itself, because I think the arrow of time is related really to entropy. So, you know, the entropy which pretty much increases, and that somehow defines the way how we perceive time flow.
Well, without time, nothing happens.
If the fine structure constant, alpha, should change with time, depending a bit on how you define your units and things, you can see this as like the electric charge changing with time. And then I worried some years ago about if you had a maximally charged black hole and the electric charge were to change, would you violate cosmic censorship? That is, would the black hole disappear and would you have a naked singularity, or would it violate the generalized second law of thermodynamics and reduce the horizon area? And there are all sorts of spin-off questions of that sort that would be opened up if it turned out even microscopically, a tiny amount, if the fine structure constant should vary. So that's my main interest in it. Of course, not just fine structure constant, but all of the fundamental constants of physics, because we want to know, is there a final theory that would produce these constants as part of the theory's output? Are these numbers, like the fine structure constant, just arbitrary, or are they connected to a body of mathematics that nobody has yet put together? It's always been my dream of deriving the fine structure constant, which famously has this value close to 1/137, deriving it from some fundamental theory. And I tried to do that many times over my career. I've returned to that thinking, well, you know, sometimes I think, is there a nifty mathematical formula that would crank that out? So even though you didn't have a theory, you'd have a formula. Well, nobody's found one yet.
Going beyond, so trying to go back beyond that is effectively completely unconstrained, because as soon as your ability to measure and model what happens breaks down, the possibilities also effectively, I think, break down. And so saying, how do you track back to the point of origin, to the singularity at the start of the universe, okay, we can get that far, or very close to it, but going back beyond that then effectively becomes meaningless, at least from my view, because before that, anything and everything could have happened, but the point is everything effectively got reset at the point of Big Bang. When the Big Bang kicked off, everything got reset and the universe we know it came into being. And therefore what happened before that is both untraceable and in some degree, it sounds slightly arrogant, but also irrelevant, I think, because I don't think has had much impact on the universe as we observe it around. It's not terribly relevant to what we see and what we do and how the universe evolved, and therefore what happened before the Big Bang is kind of an interesting open question, but it gets more into the kind of speculative, slightly softer side of things in terms of astrophysics rather than dealing with observables and testables, which is what I like.
We've just got no way of knowing, in the framework of our current ideas and our current theories. Doesn't stop people speculating, but it's where you move from being science fiction to being just fiction. At the moment, we've no way of testing it, no way of finding out, no measurements that we can think of to make. So you could come up with any idea or any hypothesis, and it will be equally valid at the minute. No way of testing it, so it wouldn't be a scientific idea, but it's not something we can really approach and understand with our current way of thinking.
If we don't have the instrument to actually probe that particular idea, then what's the point of actually doing it, studying it at all? But you need people like that. I mean, take for example, probably the most famous scientist of all time is Albert Einstein. He dreamed up this model of theory of relativity. At the time, we couldn't really confirm certain things. There was things that came out, like sort of the bending of light around warped objects, and such even a sun, because you need a total solar eclipse to see the warpage, if that's even a word, but sort of seeing the observed starlight with and without the sun, and actually there is a discrepancy of about 1.75 arc seconds, and that was actually predicted by Einstein. So as soon as that evidence came on board, Arthur Eddington from England at the time actually vindicated sort of Einstein's ideas at the time, and that just blew out. As soon as we had the evidence to confirm this radical idea, then people start taking notice.
No, I think I've because you're asking about responsibility of cosmology to answer these philosophical questions, yeah? And I don't think cosmology has that responsibility, but cosmology is supposed to study universe as a whole, and I think at certain stages it was all limited to observable universe, and fair enough, that's what we can study. I mean, when you start to talk about something which we can observe, which we've got some theories about, then you start to merge both of these sort of areas. You merge philosophy with actual cosmology, science we can do, but otherwise I think, you know, it's yeah, these areas really sort of overlap a little bit. Yeah. You go from being special and unique and interesting, and suddenly like, well, we're just part of the thin veneer on top of dark matter and dark energy again. And it's like, it's slightly sad in that respect, but you know, it's in that regard, yeah, it would be slightly depressing, but at the same time, it would also be very interesting, because if you can look at that and go, look, these things are repeatable, and there's clearly a periodic mechanism, perhaps even, that traces the evolution of a universe, or of universes, then suddenly it becomes a lot more interesting, because we're highly unlikely to be the first time this has happened. So if it's periodic, it's like, well, how many times has it gone before? Can you test that? Can you see? Can you put in variations? Can you affect the universe? I mean, it's highly unlikely, and it's on scales way bigger than that of human reason, but certainly it's of interest that suddenly, is it possible to sort of look at these questions from not just a
personal perspective inside the universe, but actually look at it from a universe perspective inside a multiverse. And that suddenly becomes a lot more interesting and starts to drift towards philosophy, but it suddenly becomes a lot bigger and a lot more interesting in terms of the space you have to deal with as an astronomer and as a scientist.
So we live in this infinitely complex universe. We're not infinitely complex, so we make stories to explain it, we come up with hypotheses, we test them. And that's how we advance our knowledge and our understanding. In the current framework of what we understand, what we can perceive, we've got no way of doing that, but that's based on our current understanding, that's based on the current techniques we have, the technologies we have. At 50 years' time, the world will be entirely, utterly different. Not in terms of the physicality of what is, but in terms of our understanding will have increased leaps and bounds. The technology we have to analyse things will have increased leaps and bounds. And there will be new vistas opened up by that new technology. And it would be very foolish to limit what I think that we could do in the future. So if you think going back 200 years, people were saying you could never have heavier than air flight. 100 years ago, they just started doing it. 50 years ago, we had people walking on the moon. It's amazing how quickly things move on, and if you try and predict that kind of development, it's almost impossible. The only thing that you can guarantee that you can predict correctly is that you'll be wrong in the predictions you make, and even then, you're rolling the dice on it. So we might be able to work it out. It may be that the models we have for how the universe came into being and developed that we have now change as we discover more with the next generation of telescopes, with the next generation of experiments at the Large Hadron Collider, things like this, and that gives an insight closer to the Big Bang itself and may even start shedding light on, if there was a before, what came before. But that's beyond what we can say at the minute.
And if everyone agrees on how you conducted the experiment was appropriate and valid, if I use the term that now they're using U12 HSC syllabus, validity of the experiment, then people will actually start listening up. Because once the evidence there is plain and everyone agrees on the evidence, saying favours one model over another, or favours one theory over another, then we can actually move forward. And that's essentially what science is. Really is to disprove models and to favour others. And nothing in science is actually fully 100% proven. In fact, I don't like the word proof in a sense, because it's just giving the wrong impression of what scientists do. They actually want to confirm ideas and theories rather than saying, yes, that's 100%. It's got to be fluid. And that's what I like about science, is because we are limited in our sort of ability to take measurements, but we're not limited in the ability to imagine what's actually out there, of course.
Although science has defined our universe, from the Big Bang to the present with a confident analysis of the future, questions continue to evolve with our discoveries, leading us deeper into an alien reality far from the world we know. What caused the Big Bang? Was there a beginning? Is there an infinite amount of space, and if so, an infinite amount of possibilities? The journey to understand the complex and extreme circumstances of the Big Bang is an amazing accomplishment and perhaps the greatest intellectual human achievement to date. And one can only imagine what cosmological discoveries the future may hold.